Okay guys, hi. We're here to talk about types of data and how we display them. So before we start analyzing data, it's important to know what data is. Okay, and before that, we even need to know what statistics is. So let's start with statistics. Statistics is the discipline that concerns the collection, organization, analysis, and interpretation of data. There's so much more to math than just arithmetic and algebra, and this unit is a perfect example. We collect information, we organize information, we analyze that information, and then we interpret it. That's statistics. By the way, data is a plural word. Okay, it's a group of data, a bunch of data. One piece of data is actually datum, D-A-T-U-M. That's the singular form. So data are units, sometimes numbers, sometimes not numbers, that are collected through observation. And that observation can include surveys, by the way. Okay, it doesn't have to, but that's one way we can observe things. All right, now there's two main types of data that we deal with, qualitative and quantitative. Now, qualitative data is descriptive, describes things. Descriptive data that is not in the form of numbers. Things like your graduating class, whether you're a sophomore or a junior, or do you have brown hair? These are descriptors. They're also categories, and qualitative data is also called categorical. So categorical data, it's the same thing. This kind of data describes the qualities of something or the categories that they fall into. Now, quantitative sounds like quantity. Quantitative research gathers data in numerical form. This type of data can be used to construct graphs, and tables of raw data. That's the data before we analyze it. Things like that might include a person's height, it might include age, it might be the time or the length of time that something happens. Those are all quantitative pieces of data. Now, once you have your data, you have to choose an appropriate display for this data. Okay, and that's going to depend on whether the data are qualitative or quantitative pieces of data. So, if we have quantitative data, now remember, quantitative, those are data that can be measured by numbers. Some ways that we might represent that type of data might be in a histogram. We might use a stem and leaf plot. We might use a box plot or a line graph or a scatter plot or even a dot plot. Okay, now the categorical or qualitative data, remember that's one that can be grouped into collections of categories or qualities. That we might use a frequency table. We might use a pie chart or a circle graph, or we might use a bar graph. Okay, those are the types that we would use to represent those types of data. All right, now you may or may not remember each of those types. Some may be more familiar to you than others, and that's okay because we are going to review them so you remember what they are, and some will use more than others. Okay, so let's go and take a look at some of these representations. Representations of quantitative first. So the quantitative, these are the numbers. So we have a line graph. The line graphs show data over time. So for instance, on the horizontal label, we have the months of the year. On the vertical label, we have the population. And notice the scale on the vertical, 0, 200, 400, 600. It's a consistent scale all the way up the vertical axis. Notice the labels. Notice there's a title. All of these things are important in a line graph. You have points that are plotted, and then you have little line segments that connect them. Each one of those things is very important when making a line graph. Next comes the histogram. Histograms show the frequencies of data values in intervals of the same size. Each of these bars is the same width. If they're not the same width, it is not a valid histogram. Okay? They have to have intervals of the same size. Okay? Also, it's got a title, labels on the x-axis, labels on the y-axis. Okay, notice that the bars touch each other, and that's one of the big differences between histograms and bar graphs. Histograms have no gaps between the bars, and they're used to display ranges rather than a specific number. If you look at these bar graphs, it's going from about 0.5 to 1, then from 1 to 1.5, and then 1.5 to 2. So it's a range of numbers, not just at one number or one category. Okay, and we'll talk more about histograms. Then you have your stem and leaf plot. Okay, these order numerical data and show how they're distributed. So here we have the per capita GNP, gross national product, for Western Africa. So when we have the stem here, that's the first digit of the number, and then we have the leaf. So the data here would be 180, so that means an income of $180. Then the next row, we've got a 2 with a 40, so that's 240, a 2 with a 60, that's 260, a 2 with a 70, that's 270. Then in the next row, we've got 3 followed by a 10, that's $310, 3 followed by a 30, 3 followed by a 60, 3 followed by a 70, and 3 followed by a 90. But the nice thing about the stem and leaf, we get to see that more of the data falls in this 300 range, okay? And there's nothing in the 600 range. So it's nice to see the data arranged this way also. Next comes your box and whisker plot. Now the box and whisker plot shows the variability of a data set by using quartiles. That's when you divide it up into 4 parts, and it's divided by percentages. It's not that it's evenly spaced out. You have your lowest over here, you have your highest over here, you have your middle, and you're going to have 25% in here, the next 25% in here, the next 25% in here, and the last 25 in there. Okay, so it's broken up into 4 groups of 25%. And the box part is around the middle 50%. So the box part is around the middle 50%. And you can see that the boys' 50% is very different than the girls' 50%. The girls are more clustered together. The boys are more spread out. The girls seems to tend up, it's inside. They don't get as tall or as short, but they're more clustered together there. Next, we have a dot plot, which is a little bit reminiscent of, it's kind of a combination of some of the others. So here we see that we have 1, 0. We have 1, 2, 3 dots above the 1, 2 dots above the 2, 3 dots above the 4, 4 dots above the 3, 3 dots above the 4. And that tells you how many goals were scored. So there were 3 games where 4 goals were scored. There were 3 games where 5 goals were scored, 3 games where 6 goals were scored, and 1 game where 7 goals were scored. Now, in all honesty, there isn't another label on this, so I don't, and it should have a title. It's not a great graph because I don't know, is this how many goals were scored in each game, or is this a particular player's record? Okay, so there's some information missing on this graph, and that's something we're also going to talk about in this unit, is graphs that aren't complete or they're misleading. Okay? Next comes your scatter plot. Scatter plots show the relationship between two different data sets by using ordered pairs, just like when we're graphing. So here we have the cricket chirps in 15 seconds, and then we also collected the temperature in degrees Fahrenheit to see if there's a relationship between the temperature and how many times a cricket chirps. And each one of those dots represents a piece of data that we collected. Now let's look at some of the representations of quantitative data. So here is a frequency table. Now notice the ages are grouped. So you're counting how many people fall into a category or into a group, an age range. A lot of times you'll see that this is called like the range of the ages here. Okay, do you fall in the 0 to 9 group, the 10 to 19? Most of you fall in this category, right? Between 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. And if you want to know how many people were surveyed altogether, you would add up all the numbers in the frequency. And then you would know how many people were surveyed altogether. So that would be 9, 16, 22, 23, 25 people were surveyed. Okay. Now a bar graph. Now remember, we said this is different than a histogram. Notice these bars are not touching. Okay. Also, the bottom axis here, they have categories on them. So this, we have a title here. It's the school supplies that students use. The types of school supplies are on the horizontal axis, so those are the categories: pencil, scale, pen, sharpener, eraser, okay? And they have to be labeled. Then on the vertical axis over here, which is usually our y-axis, we have the number of supplies. And these are numbered 0, 1, 2, 3, 4, 5, 6. Now the heights of the bars tell you how many of each type there were. There are 8 pencils. There are, follow the red arrow over, 3 scales. Follow the arrow over, there are 2 pens. Follow the arrow over, it's 5 sharpeners and 4 erasers. Okay, but the scale is important, the labels on both axes, the title, the labels of the categories, all that stuff, the scale on the axes, it's all important. Next comes the circle or the pie chart. So here, we're showing the data as parts of a whole. And it's important to realize when you're dealing with these percents, the percents should add up to 100%. If they don't add up to 100%, it's not a valid graph, okay? And it's showing you in relationship to each other. You can see that how much water do we use? We use most of it on the toilet, whoever this was. This was the American Waterworks Association Research Foundation from 1999. That most of our water was used by toilets. Then came the clothes washer, then the showers, then the faucets, then leaky faucets, leaks we have, and then other things that we're using, maybe watering the lawn or whatever else we're using, okay? So this is a nice visual representation so you can compare how much of one thing to another thing. Let's practice a little bit. Let's first decide whether the data are qualitative, remember those are categories, or quantitative. Those are numerical pieces of data. So the prices of used cars at a dealership. The price of a car is a number, so that is quantitative. Lengths of songs played at a concert. How long a song is, that's another number. That's quantitative. Jersey numbers on a basketball team. Again, jersey numbers, they're numbers. That's quantitative. And zodiac signs of students in your class. Now, zodiac signs, now you're talking Scorpio, Gemini, Aries. Those are not numbers, those are categories. So that we would say is categorical or qualitative. One more set. Let's choose, and there are many answers for this, not just one correct answer here, but choose an appropriate data display for the situation. How about the number of students on the debate team each year? the number of students, now that's numerical. I might use a line graph on that one, where I have the number of students over here, and I have the year down here. Okay, I might use a line graph. Let's try another one. How about a comparison of people's shoe sizes and their height? We have two things we're comparing, and we want to see if there's a connection between people's shoe sizes and their heights. I would probably use a scatter plot for that, to compare two things to see if there's a connection. That way I would use a scatter plot. Now next, we have the population of the U.S. divided into age groups. That word groups, that's categories. So we'd have to make sure it's one of those categorical type graphs. Age groups, you know what? I might use a histogram for that. And again, it's not the only one, but I might go with a histogram. And then the percent of students in your school who play basketball, baseball, hockey, soccer, or football. As soon as I see percent, and it's not always the way to go, but I tend to think about a pie chart, and I could figure out, which percentage and break it up so I could see a comparison, a visual representation of what percentages each kid plays of the sports, what percentage of the sports the kids play. Okay, so that was an introduction to data and types of data and how we can represent them, and we'll do some more work with that when I see you in class. All right, guys, have a wonderful day. Bye.